I'll use a slightly different style today because I think some parts of the presentation will not be suited to asking you so many open questions. So that means I even more would encourage you to ask questions in the chat or to give comments in the chat when you think something is unclear or you think some argument was left out. Feel free. Of course, you can also use the hand raising function to let me know that you want to also give a verbal comment. That's also much appreciated. So although I might ask less open questions to the audience today, you should still feel encouraged to actively participate and bring in your thoughts and ideas into the lecture. Might also be better for my vocal cords if there are some interruptions to me talking. Okay, so what we will start with today is quickly finishing up the slides on the theory. So far, we've talked about possible effects of disasters on different outcome dimensions, on individuals, on the economy, on politics. Now we will take a brief look at disaster mitigation and prevention. And what you first need to understand is that disaster prevention is of course an activity, although we very often ascribe responsibility to the government, it's of course just as well a private and individual activity. So although we often talk about the government having a responsibility to invest in disaster prevention starts with the individual, which means you can shield yourself from the impact of disasters, for example, by choosing where you build your house, or choosing in which way, with what materials, with what technology you build your house. So things like that have a huge impact on your exposure and your vulnerability to disasters. So governments always can only complement that. And the reason why we focus quite a bit on governments is the idea that governments have economies of scale in providing preventive measures. So if not every one of us does it individually, but the government provides some things collectively, that might be more efficient. And it's very obvious in some cases, like if you want to build a dam, that isn't something that citizens could simply organize by themselves, or let's say everyone throws $100 in and then you build it together. But these are large infrastructure projects which are needed. And here the government clearly has to fulfill a function in solving this collective action problem that otherwise would exist. So governments clearly, although it starts with the individual, governments clearly have a role in fulfilling particular and sometimes very important functions in preventing, not necessarily completely preventing a disaster, but preventing most of the adverse consequences of disasters, including a high death toll. Of course, government intervention does not come for free. It's not a perfect instrument. It has its disadvantages. And one of them is that the government socializing the costs of a disaster can mean that private individuals will not sufficiently account for the costs of the disaster themselves. So if, for example, the government is willing to provide people with preventive equipment or subsidizing their building of safer housing that is more stable, that is more resistant to a disaster and things like that, that might create incentives for individuals not to take into account the costs that they are creating if they, for example, decide to settle in areas that are more prone to disasters. So this is something that should be taken into account from a policy point of view. On the one hand, government intervention is very helpful and often needed because of collective action problems, because of economies of scale. So governments can solve some problems simply more efficiently. On the other hand, it creates adverse incentives. It might create incentives for individuals to take more risks because they know that the government will step in and will take costs, will carry the cost or will carry parts of the costs of preventive measures against disasters. In general, this is not on the slide, but you can think this argument one level further, and this is an argument that has been made in the literature. The same problem might exist between governments and the international community. So it has been argued in the literature that governments might take less preventive measures if they anticipate that the international community will support them financially in case of a disaster. So the idea there is also a moral hazard problem. The idea there is also that the government takes more risks on behalf of their citizens, invests less in prevention if they know that if a disaster occurs, they will be financially supported by the international community. So then they are socializing some of the costs of the disaster to the international community. There are no easy solutions to these problems. This is discussed to some extent in the literature, but it's definitely something to be aware of. That whenever you create such insurance schemes, whenever you are socializing costs of such events, you have to always have an eye on the adverse incentives you create. In general, and this is something we will take a look at soon in empirical studies, in general we expect that governments that are more accountable to their citizens and that are more transparent, so where citizens can more easily check what the government is doing and whether the government has been preparing well, has been spending well, etc. They should invest more into disaster prevention because otherwise they might be punished by the citizens either via elections or via protest, unrest, etc. if citizens are unhappy with how the government has performed. So the idea is the larger accountability, the more transparent the government, the more investment we should see into preventive measures, and this is something that has been tested empirically. There's also the possibility to mitigate harm exposed. This is where the government most certainly needs to become active, particularly when lives are threatened. And we've already heard that vulnerable groups might be affected more by disasters, and sometimes they would simply be lacking the means to help themselves in these situations. So the government often needs to provide at least food or basic commodities, basic housing, shelter in such disaster events. And usually the private parties could not organize this. Again, there is, if you do that, you create a certain moral hazard problem with that, but it is generally agreed that there is not really an alternative to that. So the disaster mitigation is to some extent carried by the government, but of course other parties come in. I've already mentioned that insurance plays a big role, but also private parties, so people, for example, sending money, sending remittances to their country, if that country is affected by disaster. So this could be foreign workers, nationals that live outside the country, also foreign governments, and of course international organizations are often involved in disaster mitigation and providing goods for basic need. So they often provide some basic goods and some financing to finance reconstruction and to some extent mitigate the humanitarian costs of the disaster. We will look a bit more at the role of private insurance, and there have been some people who argue that to mitigate the economic costs, private insurance is very important. So of course you cannot insure yourself against death in the same way. If you die, you die, and the insurance will only help your relatives and not yourself. But for the economic damages, it's of course different. If you are insured and the reconstruction of your house is financed then by the insurance company, that largely mitigates the adverse effect of the disaster. One final comment here. There's often some discussion about the role of the government and the role of the market and the individual. And I think it's pretty clear that in general, free markets help in mitigating such adverse effects of disasters by improving resource allocation. But there are limits to that. So if you, for example, need to impose price limits on drinking water such that people get affordable drinking water, and not some people are simply not getting water or food because some interests might exploit the situation and might charge monopoly prices temporarily, which some individuals could not pay. So if you want to avoid that, the government has to either provide these goods itself, or it has to introduce price controls. But these things only play a very limited role. To a large extent, market mechanisms will actually help in channeling resources within the economy to the places where they are most urgently needed. What about financing for a specific disaster? For example, people send much more money than is needed. I'm not sure if I fully understand what you mean by this financing for a specific disaster. Maybe you can also, if you want to say it's in audio, you can as well.
My point is, for example, this happened, in Iran when, it was an earthquake in Kermanshah, and people sent, so much money that people in there just said, stop sending us money. It's enough. We have enough money to get things better. My question is, this.
Yeah, that would be an exception. It's an interesting observation, but usually the destruction far outweighs the donations or remittances or the support by the international community. So usually they only finance a share of the cost of the reconstruction. Something like that might, of course, happen if, for example, an event gets a lot of media coverage. Then people might simply react to being exposed to the media coverage and seeing the adverse effects. And then if many people react to that at the same time, then suddenly there might be a large inflow, and maybe unexpectedly large inflow of money, which is beyond what is actually needed. This might be also the case if there is a relatively large death toll, but not so large economic damages, because again, if you see human suffering, you might be more prone to donating, while the economic damages might not be that large. So I don't know that individual disaster, so I cannot say anything about that particular case. But this can, of course, happen in individual cases, but it's not systematic. It's not like you can make a business out of having disasters and then getting more money than what it costs you. it tends to rather be the case that you carry a large share of the burden yourself as a society. But of course, these remittances, these donations might be also a reason why it's difficult to measure adverse growth effects of disasters, because if you get a lot of external support, that means that you don't have to carry the full burden of the disaster. You don't have to pay for every damage that was caused, but some of the damages will actually be covered by other parties, and then you will see a much smaller effect on GDP, for example, than what the disaster actually destroyed and what would have been the consequences if others didn't help. Yeah, that's also an interesting point. Yes, money inflows can lead to corruption. We'll talk about that a bit more. The political economy of disaster help and donations and stuff like that is quite interesting, and one can expect that there will be more corruption if there's, for example, more foreign aid, because this is something which we generally observe with foreign aid, not only disaster aid, that of course it creates incentives to channel that into private pockets. Good. I think the other questions in the chat seem to have been addressed. So I'll close these slides here because we are through with the theoretical considerations. So to sum up everything, we looked now at the individual level consequences as well as economic and political and social consequences. And we discussed to some extent problems with prevention as well as ex post mitigation of disasters, but we will also see some of these aspects in our discussion of individual studies. So this was just supposed to give you a brief theoretical framework of how to think about these things on a very general level and in a way that it could apply to many of these individual studies. Okay, before we move on to the economic effects of disasters, you might have had a look already at slide set number 3, which deals with measurement, because I think that was a big challenge in the home exercise that you had to do, was thinking about trying to figure out how do I actually operationalize disasters? How do I make them measurable for empirical studies? And we'll now go through a short discussion and some of the problems that you might have faced yourself, you might have thought about yourself over the last day. So the problem here is, or the challenge here is, that we have many degrees of freedom how exactly we measure, how we operationalize disasters. So how do we attach a particular number to a disaster event or a number of disaster events? How do we measure when disasters should matter and when they shouldn't? And the most important point to be made here is that, of course, there is not any universal answer, because depending on what research question you're after and what countries you are studying, different operationalizations might be differently suited to your empirical analysis. So we will discuss trade-offs here. We will discuss things to consider, but I cannot tell you in the end, this is the right way to measure disasters. And there is not any consensus in the literature. We will see that when we go through the empirical studies. You will see that people are measuring disasters very differently across different studies. And this leads probably to also problems regarding publication bias. So it's very well possible that some of the results that we find in empirical studies would not be robust to to using alternative measurements of disaster impact. So more recent and more rigorous studies have, of course, done extensive robustness tests, but some of the not so well published or early published studies might be quite vulnerable on that front. They might not hold up to robustness tests using alternative disaster indicators. So this is something to always keep in mind when you are reading these studies, that if you choose one particular way of measuring disasters, it's not necessarily the case that this is the best way to measure it. It could also be the way which simply gave you the best results, and then you are submitting the article in a way that it shows the best results that you could find to increase your chances of getting published, which of course from the point of view of the scientific community is very unfortunate, but which might be individually rational for researchers given their own career incentives. Okay, so one question simply to you would be, how would you approach this? How can we measure disasters? And you've already dealt with this, at least many of you have dealt with this yesterday in the exercise. So I will ask you maybe to just repeat how you did it yourself, or briefly think about ways how we can measure disasters. So to be precise, what I mean by measure is, how do we count disasters? How do we quantify how sizable, how important a disaster is? What numbers could we use? So you can, I'm not sure if Hadisa is still raising her hand from earlier, or if you have a verbal comment. It's disappeared, so it might have still been from earlier. But you can also just write into the chat some suggestions. Yeah, you should choose the right and available indicators, but usually you will have to do work beyond that. As you have seen with our own data sets, the MDAT data set, it comes in a very crude form. It simply gives you information like the number of people affected, whether there was a disaster, the number of people killed, things like that. And then the question is, what should be your variable in your analysis? Yes, so we could aggregate the number of people affected as one suggestion. We could use dummy variables. So I assume a dummy variable simply for whether a disaster occurred. This would be the most simple way of measuring disasters. Of course, one could construct other dummy variables. We will be talking about that. We can create our own indicators. I think the suggestion goes towards some sort of physical measure. This is actually not what I will be focusing on here in the discussion of the measurement, but we will see this in at least one of the empirical studies, that one way of measuring disasters is, of course, looking at physical intensity indicators. So for an earthquake, for example, where are they on the Richter scale? For a storm, I'm not sure what's the correct English term, the strength of the wind, how fast the wind was, for example, at peak in that storm, and things like that. So you can measure the physical intensity. We will primarily focus here on how we can use the MDAT data, so the data which relates to the occurrence of disasters that affect people, and the question how heavily populations are affected. Okay, there are there's a bit more typing going on. I'll nevertheless slowly move forward. I just still try to have an eye on the chat. So a very basic way of measuring disasters, actually the most basic way, I've not even listed on my slide, but it was mentioned in the chat. We could simply have a dummy variable telling us whether there was a disaster in a particular year or not. Then the question is, what is a disaster? But for our purposes, or for the purposes of the data set that we are using here, we've already discussed this yesterday. At least 10 people would have to be killed, at least 100 people would have to be affected, or there would have been a call for international assistance or a state of emergency due to the disaster event. So if one of these conditions is fulfilled, we have a disaster, and then you could simply use the dummy variable, is there a disaster or not? Now the problem here is that this dummy variable is a very, very crude measure for whether a disaster occurs and how severe the disaster is, because you simply ignore how many disasters there are, how big these disasters are. So you are simply mixing up different numbers of disasters and differently intense disasters with very large numbers of casualties and very small numbers. So this would be a very simplistic approach of going at it, one that you will not find in the literature, but what you will find occasionally is that people simply count the number of events. Or actually, I see, I actually listed this as an option, that there could be a dummy as well. Sorry, I overlooked that. So, but counting the events actually happens. This was used in published research. So one problem with that is obviously that we are not distinguishing how big these events are. But this is a problem that we are accepting when we are choosing such an indicator. There might be another problem with simply using a count that we might not be fully aware of if we don't fully understand the characteristics of the data set. And this is something that we discussed earlier, and this is the question of data quality. When we are simply looking at the count of the number of events, we are assuming that small disaster events are equally likely to be reported in different places. And we've seen by looking at the data that this is very unlikely to be the case. So it seems that over time, the reporting of small events became more likely. Moreover, we can expect that small disasters are also more likely to be reported in countries with free media, with better statistical infrastructure, etc. So this would lead to a substantial bias in where we measure events, because we might see an enormous number of disasters in the United States, for example, or in some other big and relatively developed countries, simply because they count all these tiny disasters. They have information on all of them. All of them are discussed somewhere in the media. And so they end up in our data set, whereas in other countries, let's take, for example, China, where we've heard that particularly during certain years, certain political regimes, reporting was quite limited on disasters. We might have very, very few events in our data set, although given the size and given the population of China, you would expect that there are very many, and also given that they are partially exposed to natural disasters due to their geography. So there are certainly some problems with such count measures. We could make things a bit more refined by continuing to work with a dummy for the occurrence or with a count measure, but we could start distinguishing, for example, different types of disasters. So we could start measuring how many floods were there and how many earthquakes were there. And this could already to some extent mitigate the problem in the sense that maybe we are not missing very many earthquakes. So the earthquake indicator might be quite reliable, whereas an indicator of landslides might then lead to more biased results because there the reporting quality really matters. And you will often not find information on these things happening in particular countries. We already discussed some problems here in the student presentations that are also here on the slides. So one question concerns how to deal with events that stretch over longer periods of time. So if we have a disaster that occurs in 1 year but which continues into the next year, should we then count this in each year, or should we count it only in the first year? How should we deal with that? Or the solution that I already mentioned earlier, we could divide it up between, for example, the first and the second year, depending on in which month of the first year the disaster occurred. But we need to have a rationale, we need to have a reasoning why we choose to deal with this in a particular way. So all of these are questions that we would have to answer. We can also think about how do we deal with events that affect multiple countries? Are they somehow different? Also, do we expect that events maybe affect neighboring countries? So do we expect spillover effects? So if there is an earthquake, does this maybe also harm the economy of my neighbor, because the economy of my neighbor might depend on trade with my country? And we've already discussed, you could say, the opposite way of thinking, that aside from looking at neighboring countries and multiple countries being affected, we could also ask the question, is it maybe possible to measure disasters within a country based on their location in the country, so that we, for example, distinguish different regions of the country and we measure in which region exactly the disaster strikes and whether this region is then particularly affected. So even if we use these very basic indicators where we only ask, did a disaster occur or how many disasters occurred, we already have to answer quite a number of questions. And all these different questions give us degrees of freedom that we can deal with differently. So that is already, yeah, you can see it optimistically. You could say that's nice because I can tailor my measurements towards my specific research question. But it's also a problem because, first of all, it means work for you if you want to work with such data. And it also means scope for abuse. So people presenting their results, you some extent have to trust that they have not been playing around with the data until they found the right results. So maybe at the beginning, they only counted the disaster in the first year in which it occurs. That gave them insignificant results. Then they tried out, okay, now if I count the disaster in every single year which is affected by the disaster, does this change the results? And then maybe suddenly they get different results. And we've not even discussed the question whether we should consider things like time lags, which is not done a lot in the literature. So disasters usually are studied for their contemporaneous effects. All of this discussion is kind of boring because we are really dealing with very trivial, very simple indicators. So maybe we want to move to indicators that more seriously try to measure the intensity of disasters, because 100 small disasters might not really be what we are interested in. So since disasters are very different, we might want to move towards counting not the occurrence of disasters per se, but we might ask how many individuals were affected, killed, or how large were economic damages. Economic damages is something that we rarely use, and we've already discussed this earlier in the lecture, for example, due to the limited availability of data regarding economic damages. So there is a question of how precise this information is, but beyond that, there's also the question how long time periods can we really cover with reliable information, even if you trust the more recent estimates of economic damages of disasters. If you have these numbers, if you are looking at how many individuals are affected or killed, an obvious question would be, do you expect a linear effect of that? And this is also some thoughts raised in the student presentations where someone suggested maybe a variable should be logged. And if you take the log of a variable, you are changing your argumentation, and you are no longer saying, if I increase the number of individuals by 1, this is what's happening, or by 1,000. But then you are moving to a relative effect. So you are asking the question, if I increase the number of individuals killed by 1%, how does that change the outcome? And by that you are effectively saying, if I'm moving from 0 to 1,000 casualties, that does not mean the same thing as if I'm moving from 1,000 to 2,000 casualties. It's not like it's doubling the effect, it's doubling the consequences, but maybe the first 1,000 people that are killed are much more important than the second 1,000 for whether this will have an effect on the economy. So you should somehow discount larger numbers to some extent, and there is not necessarily a linear relationship. So one can think about this. You can make arguments about this. It is in the end a theoretical question whether you expect a linear effect here or not, and it depends a bit on what outcome variable you are studying. And you will see that whenever we discuss some options, I will always ask, but is there not a problem with this option? So first, we simply took the occurrence of disasters as a measure of disasters. So either binary or as a count. And then I said, okay, but we might want to take into account the intensity of a disaster. So we might want to count casualties or the number of people killed. But then there is a potential problem, because the same number of people killed to one country might have a different meaning than the same number of people being killed in another country. So if I kill 100 people in China via an earthquake, that might have very different consequences than if 100 people are killed in Luxembourg. And it might also represent a very different disaster. So 100 people killed in China might be a very, very local event somewhere in the countryside, which is unfortunate to some city, some small city affected. But it doesn't mean that there was a disaster in the whole country of China. Whereas if in Luxembourg 100 people die, Luxembourg is very small for those not familiar with the country. It's more like a city than a real country. And if Luxembourg is affected and 100 people there are killed, then you can assume that almost all of Luxembourg was affected by that natural disaster, or large parts of that country were affected. And then you would expect different consequences. So therefore, we often, and this is something which was already discussed on Monday, we oftentimes might want to normalize such data. And normalization means we divide by something to which we want to relate these absolute numbers. So we might divide, for example, by the population size when we are looking at the number of casualties. We might divide by the GDP if we are looking at the economic damages, because $1 million economic harm to the United States will be very different from $1 million harm, let's say, to Tunisia. It's just very, very differently sized and very differently rich countries, and $1 million to one might not be much, whereas $1 million to the other might be significantly more important. Another option which is not mentioned here, but which is quite commonly used, is normalizing by surface area. I think I mentioned this already today. So you can simply take a measure of how big, how sizable the country is in terms of area, and you can divide the number by that. So you would then be asking how many people are killed per square kilometer, so to say. Now, a question to you: do you think that these normalized numbers could also be misleading? Could there be a problem with that? Why might that not be the ultimate solution? So one problem that we clearly face is that such a relative effect might also be difficult to compare, because we might have a sizable event in China which destroys one major city, but relative to the size of the country, this will not matter much. So you might have important events, big events in large countries, but if you always divide by the size of the population of China, or by the size of the surface of China, or even worse, the surface of Russia, in relative numbers, disasters will always be tiny in these big countries, which means that you will kind of have to not only take this into account, not only this relative number. You can also have the inverse problem. In Luxembourg, for example, you might have 10 people killed because some building collapsed. And although that would not be a natural disaster, but maybe the building collapsed because of a storm, one building collapsed, 10 people are killed. But that's due to the small population of Luxembourg. That's a significant share of their population. So very many people in China would have to die in order to have the same share of the population to be killed. So the question is, can we really rely solely on these relative numbers? We might still want to somewhat account for the absolute size of the disaster and not only for the relative numbers, because that would always mean that there will be, it's much easier than for disasters to occur in small countries in terms of population size or in terms of surface, and it will be very difficult to find disasters in countries like China or Russia with a large surface and population, which means that effectively they will be almost unaffected by disasters, because these disasters are always local events. So yeah, Mariam is proposing to normalize it in terms of casualties per square meter, but this is what I mean if I say normalizing by the size of the surface of the country. So this is per square meter or per square kilometer. But nevertheless, this would make it almost impossible for disasters to occur in Russia, because simply the country is very, very large. But we can have important disasters in a country like Russia. So if we only look at relative numbers, we might have the opposite problem that we have if we only look at absolute numbers. When we look at absolute numbers, we might have an event in China where 100 people are getting killed, but that's not really important because 100 people don't really matter relative to the size of China. But if we only look at the relative numbers, we might then not find any disasters anymore in China, because then every disaster relative to the size of China becomes tiny. If we have subnational data, we get rid of a lot of these problems, yes. In almost any application, we don't have that. But you are right, some of the problems that we are discussing here are due to the fact that jurisdictions are of very different size. So we have very big countries in our data sets, and we have very small countries. And to some extent, it's maybe realistic to move towards regions within countries. But even a region in China is more like a major country in Europe, and not really comparable to a region in a country in Europe, for example. So yeah, one can certainly improve on these things by moving to the subnational level, but then again, very often our data does not exist on the subnational level. So this would be more of a textbook solution than something that's practically feasible. But certainly it would be some solution in the future when data availability hopefully will have much improved due to digitalization, etc. Okay, so what conclusion could we draw from that? We might want to actually combine these criteria. So we might want to, I don't think this is the right slide to make this argument, so I'll move one slide back. So we might define both a relative threshold as well as an absolute threshold. So we could say we count a disaster as important to economic growth if at least 1,000 people are killed, and this is at least 0.1% of the population. So if you apply both an absolute and a relative criterion, you might somewhat address this problem. This is not done a lot in the literature, and there might also be problems with that approach, but it's at least a solution to think about, to consider seriously. And we will see how different studies deal with these problems. Another question that we have to ask ourselves is, are we able to actually add up disasters? So if we have 100 events that kill 10 people each, is that the same as one event killing 1,000 people? So the question here is, should we add up all the people being killed in a country year by disasters, or should we focus on how deadly are, for example, the largest disasters in a country year? So did the largest disaster in that country year kill 1,000 people, or did all the disasters together kill 1,000 people? There is not one definitive answer, but I think it's clear that if we take into account these very small disasters of 10 people being killed, again, we have this problem of having bias due to different data reporting quality in different countries. So we will then again find too many disasters and too severe disasters in countries that are rather rich, because these countries will have more reporting of these small scale incidents. Now, one thing we can do is we can actually, instead of adding up the number of casualties of all disasters, one thing we can do is we can say we are only interested in disasters that meet a threshold that is higher than the threshold used by MDAT. So MDAT reports disasters if they kill at least 10 people, or if they kill some of the other, if they fulfill some of the other criteria, so even less than 10 people might have been killed. But we could say, for our purposes, disasters are only of interest if they kill at least 100 people. And then we exclude all these smaller disasters. That gets rid of some of the data reliability problem. And then either we count how many disasters were there which killed at least 100 people. So again, we would have a count variable. Or we sum up the number of casualties, people killed by disasters, but only considering the disasters which killed at least 100 people each, which might, again, solve the problem that we are having different data quality in different countries. Again, we can define this threshold not only in absolute terms, but also in relative terms. And we can, I'll come to the comment in the chat in a second, and we can, of course, or we should, of course, provide robustness tests using different thresholds. But as you can see from the discussion that we had so far, I've already given you many options where you can go this way or that way. So the number of robustness tests that you would need to actually deal with all these choices would be enormous. So in practice, you will do some robustness tests, but there are still very, very many ways of dealing with things differently, and you will not report every imaginable result. So in the chat, there's the question whether we could use thresholds which determine, if we could determine the threshold endogenously. There are different ways of thinking about that. So you could determine a threshold based on the distribution of disasters in a country. I'm not aware that anyone has been doing that. One thing which you could say is maybe close to what you are thinking of is some people have used as a threshold percentiles. So they've not said, I want to have 1,000 people killed at least to consider this a disaster. But some researchers have said, I only consider the 1% largest disasters that were reported. And then the question is, are you talking about the 1% largest disasters in a global perspective or the 1% for that particular country? So this would be one way to kind of let the data decide what the threshold should be. Okay, now comes the slide that I already discussed to some extent. I'm not sure why I ordered these slides in this way. So this is just repeating what I mentioned, that you can combine an absolute and a relative threshold, and then say at least so many percent and at least so many people in absolute terms need to be affected, need to be killed for this to be a disaster. And of course, this creates additional degrees of freedom. Now, we've now discussed, okay, we might be interested not only in counting the occurrence of disasters, but we might want to account for their intensity, and we can do that in absolute terms, and we can do that in relative terms. But as I warned you, whenever we arrive at a somewhat conclusion to the discussion, there is a new question that arises. And the next question that I'm suggesting here is the question, if we now made disasters somewhat comparable, is this sufficient? Do we care about comparable disasters always in the same way? And the argument here is, or the thought process here is, that some countries might be experiencing major disasters according to our definition continuously, almost in every year, every second year, 2 out of 3 years, so very often. So some areas of the world are simply more disaster prone than other areas, and if we want to define a threshold that makes sense across all countries of the world, this might mean for some countries that they are pretty much in a continuous state of disaster. And now the problem is that this might not really be argued to constitute an exogenous shock, an unexpected event. And this is, as we discussed on Monday, this is what we are often interested in. So if we are saying a disaster pushes a country out of its growth trajectory, it reduces economic growth due to a sudden, unexpected, and extreme shock. This does not make much sense when we are talking about disasters that happen in this country every second year, or maybe every year, maybe multiple times every year. So we cannot really argue that such a disaster is an unexpected shock that should somehow change the growth trajectory of that country. Whereas if an event of the same intensity in absolute and relative terms occurs in a country that is not used to dealing with disasters, this might actually change the trajectory of that country quite a bit. So the question is, are we interested in these exogenous shocks that come unexpectedly, or are we just interested in the burden of natural disasters? And this can also be something that is just continuously occurring and continuously pulling the country down. So this is a theoretical question, but again, if we see that we want to have these exogenous shocks, then one way of dealing with this is that we apply different thresholds to different countries. So what we then would be measuring is not, is this a disaster relative to a disaster in another country? So is a disaster in Germany has to fulfill the same criteria as a disaster in Iran? But then we could say we define a different threshold for every country, and we only consider something to be a disaster if it's out of the norm, out of the usual for that country. So if it's something that is so extreme that we only experience it every 10, every 20 years, etc. And this could then be considered a exogenous shock. And one way of dealing with this, which has also been discussed in the literature, I'm not sure if it has been applied in the literature. I myself have been playing with this a bit, but also not in any published paper, is defining a country-specific mean. So saying in the usual year, in an average year, in this country, so and so many people are killed by disasters, or by disasters of a particular type, or by the largest disaster that occurs, etc. So we are somehow defining a mean value, and we also measure the standard deviation relative to that. So what is the typical, what is the average deviation from this mean value? And then we are saying a disaster is, for example, an event which deviates from the country-specific mean by at least 2 or 3 standard deviations, country-specific standard deviations. So this is quite technical, mathematical. I'm not sure if everyone fully understood the idea, but the thought behind that is simply to say we have a more rigorous threshold, so meaning we are less likely to count a disaster in countries that experience many disasters, and we are more willing to count something as a disaster in countries that experience only very few disasters, because in these already a smaller event could constitute an exogenous shock. Yeah, maybe Omid, if you want, you can share your work during one of the breaks. Might be interesting to a couple of participants here. Yeah, so I think we are pretty much through with the options that we had to discuss. And I hope it was not too monotonic, because it's kind of following a rhythm. You always propose a way of measuring disasters, and then you are saying, oh, this is rubbish, we should do it differently. And then you propose the alternative, and then you're saying, oh, this might also be rubbish, maybe we should do it differently. The message is not supposed to be that any of the proposed ways of measuring are completely useless and should not be considered at all. I want to simply create some awareness that there are important challenges that you are facing with each of these measures. And it's not necessarily always the most complicated measure that is the best, but if you use a simple measure, you have to think about what are potential limitations of that measure. What things could I be ignoring if I use this measure in this way? So simply think carefully about different ways in which disasters can be measured, and in practice, then we move back to the rule which always applies. The more robustness checks you're able to show, the better, the more trustworthy will be your results. Because if you show that each of the alternatives that I proposed here works and gives you the same results, then this would be amazing. In practice, I don't think this will ever be the case. But then you can still explain why maybe one indicator is more suitable for your research purposes than another indicator. Okay, this is all I wanted to say about measurement. Before we move on, are there any more questions regarding that? So there seem not to be any questions right now, but maybe we'll come back to this question when we are going through the individual studies.
Maybe I can also add something.
Sure.
Can you hear me? I'm not sure if you will talk about it later, but there's also ways to use like satellite data and other kinds of measurements. If you come to this later, I will not make some comments, but this is also a way, I think, to measure disasters. For example, rainfall data, also dust-related issues, and so on. Yeah, this is my comment. Will you come to this?
I'll not focus on this. As I said at the beginning, the physical aspects is not, because this is not done in the majority of studies. But we will talk a bit about some studies using physical indicators of disasters like rainfall, and also geocoded disasters in the sense of accounting for the location in the country. So there will be some more refined measures also accounting for physical data. There's one study looking at growth, which uses physical indicators. But if you have some comments on this already now, you can give them here, but you can also give them later when we are moving to the studies using this kind of data.
Yeah, maybe just a quick comment. Also, it reminded me when you were talking about that you want to calculate the standard deviation from the normal scenario, let's say. There's a study which you also provided, I think, from Felbermayr and Gröschel. They do the same technique with the rainfall data, I think, where they try to find what is the normal rainfall, and then if it's above the average, then it's flood or considered flood disaster or something like that, or high precipitation, and if it's below it, it's considered a drought or something like that. So I think this is also a very useful way to measure the disasters. Of course, then we have again the problem which you mentioned, I think in the very beginning, that we then see it for the country or maybe for different geographical units, but we don't know if it even affects people. So if it is a lot of rainfall and nobody lives there, so in the end nobody cares. It will not be considered a disaster. So we have also these challenges then if we use this kind of data, I think. So yeah, but I think you make a good overview about all the problems that arise when we try to measure disasters. In my paper, which also Professor Fasagan already shared, I just use the dummy. I use the provincial data from Iran, and I make a dummy if it was a disaster or not. I use the EMDA database to find out where the disaster happened. and then I make it 1 if a disaster happened. In the time period of the available data, we don't have the large disasters. So I would say it will not affect this because it's considered more small and medium-sized disasters in the whole time period. And we have usually not more than 1 per year per province. Sometimes maybe 2 or 3, but this did not affect the results. Additionally, I also then said, okay, I don't make it 1 if the disaster happened, but I make it 1 if the disaster happened 6 months before, so that we don't have the problem if it happens in December that we cannot see it in the outcome variable. I also use time lags to check for maybe longer effects. So this is maybe a simple approach, but it's also due to the fact that we don't have on the provincial level easily available these kind of data on disasters and so on. So just as a small comment.
Very good comments, and I should add, you're perfectly right. It makes a lot of sense to use the dummy variable when you are looking at smaller administrative units within a country. So my comment that this might be very crude applies primarily to the country level, where you will have many disasters and disasters of very different intensity going on in lots of countries. And then just saying China in this year experienced a disaster, then you will just have a dummy equal 1 for China in every single year, because they will always have at least 1 disaster. But when you are then looking at small geographical units, so for example, cities, districts, or other sorts of regions, then such an approach makes much more sense. So I think it's important to highlight that my maybe a bit derogatory comments towards that measurement approach is mostly meant to apply to the country level. Also, you correctly highlighted that some of the problems we see with the human impact data, they also apply to the physical data. So with the rainfall, it's, for example, the question that we might want to measure deviations from the mean. Same could be done with temperature data, for example, whereas with something like earthquake data, where we have Richter scale measures, we would probably treat that differently. There we are not there. Our baseline is usually just 0, and then we measure the deviation from 0 upwards, and we wouldn't say this the typical Richter scale value is 1 or something like that. Although these questions might not be too consequential. Just one thing I thought of, and that since I will not speak about that later, but which I think fits with your comment, is that some recent studies have moved a step forward, and I think this is very interesting to do, linking our human impact data with physically measured disaster events, and maybe even with their geolocation. So if you have a death toll of a disaster and you can link that to where the disaster occurred, in what region of a country, then you get a very interesting measure, because on the one hand, you have exogenous information. For example, the earthquake happened in this province, and it was of this Richter scale value, which is something that's uninfluenced by human decisions. You cannot prevent from an earthquake occurring and having a certain Richter scale value. But then you can use this information, for example, to instrument the death toll that occurred in that particular region, which you then take from a data set like MDAT or something more refined. So I think the future will be, and we will need a lot of work until that's really practically doable for every single study. But in the future, we will certainly start combining more the physical aspects of disasters, the physical traits, also the specific geolocation of a disaster, with information on their impact on humans in terms of physiological harm or in terms of economic damage. yeah, that's just what came to my mind, but thanks, very good comment, and yeah, everyone should read Sven's paper. Good. If there are no more comments, I would be moving to our next slide set, I think. So the next part of the lecture will be the economic effects. After that, the political and social effects, as you might have seen from the slides that were distributed, they are combined in one section, but I'm giving the economic effects a bit more space here, because I think also this is one of the big questions that economists have dealt with. What are the economic effects of disasters? Before moving to growth effects, I'll just briefly talk about one or two studies looking at other economic outcome variables. And here the study by Martin Gassebner and co-authors is interesting. They have looked at how disasters affect export and imports, so how they affect international trade across countries. And they have the theoretical expectation that disasters should reduce exports, primarily because they destroy production capacity. So if your supply chains are interrupted, if your firm headquarters are destroyed, or if your production facilities are destroyed, your machines are damaged, your workers are harmed, then you can produce less, and obviously that leads to limited ability to export. Whereas the effect regarding imports might be unclear. On the one hand, you might expect less imports because of an income effect. So people might, among other things, because they cannot export, they might not have the money to import goods, but at the same time there might be more imports because of the rebuilding going on due to the disaster. So the effect on imports is somewhat unclear, whereas for exports there is the expectation that there will be a reduction. Among these studies, I always try to highlight, at least for the first studies that we look at, how they approached measuring disasters. So what Gassebner and co-authors are doing is that they use the following criteria. They count a disaster if at least 1,000 people are killed, or the number of injured is no fewer than 1,000. It's a bit unusual, this number of injured here. The number of affected is no fewer than 100,000, or damages are no less than $1 billion US dollars, which they somehow adjusted for inflation over time. If I remember correctly, they counted these disasters, and they then divided the number of disasters by the surface area of the country. But they are also playing around with different ways of operationalizing disasters. So that is also discussed to some extent in the paper. They estimate a standard gravity model. Not everyone here might be familiar with this, but this is a standard model used in the economic trade literature, which simply assumes, like it is with gravity, that there is more, that the force pulling things towards each other is stronger the closer objects are to each other. The gravity model in trade assumes that countries should be trading more with each other if they are more proximate to each other, if they are closer to each other. So if you are neighboring, then you should trade a lot. But if one country is on one side of the globe and the other country is on the other side of the globe, due to trade costs and other factors, so transportation costs, I should say, and other factors, there will be less trade between them. So this is what a gravity model primarily does. And then they are looking at disasters occurring both in exporter as well as in importer countries. So they are looking at export flows as well as import flows. Details of that do not matter too much. Okay, so here's the information which I already mentioned. they start with a simple disaster count variable, and they don't find any effect on trade. But if they scale the count variable, so if they count the number of disasters which fulfill these criteria here, and then they divide them by the surface area of the country, then the authors find the following results. Disasters seem to reduce both exports and imports. Remember, exports, this is what we expected theoretically. Imports, this is where the effect was unclear. So it seems to be the case that also imports are reduced. They are not increased imports, simply to get materials, to get inputs for reconstruction. What they also find is that the effect on imports varies depending on how democratic a country is. So the less democratic a country is, the more imports are lost, which means that in an autocracy, there will be a substantial decline in imports, whereas in a very strong democracy, the decline in imports might be much smaller or even close to zero. And we could explain that by the fact that maybe democracies are investing more and are investing faster into rebuilding after disasters. So that is why there will be more importing of goods, because, for example, the government pays for reconstruction. It might also be that democracies receive more international aid, and that might also help them to finance imports of goods which they need for reconstruction. The effect on the exports, however, does not depend on the level of democracy, which simply means that it doesn't really matter whether you are a democracy or an autocracy. Both types of political systems are adversely affected by natural disasters in terms of their production capacity. So this is, you could say, our state of knowledge regarding international trade. I'm not aware of any studies following up on this, looking further at trade, although this study is already a few years old. But at least from what I know, this seems to be the most recent serious study on linking disasters and trade. Yeah, so maybe before we move towards the lunch break, I would say we discussed the first study on disasters and economic growth, which is also a bit different from the other studies, and I think it's a quite interesting approach, also to some here in the audience specifically. This is the study by Cavallo and co-authors, not sure how exactly to pronounce this person. So they are studying the effect of catastrophic disasters on economic growth. And by catastrophic, you already can guess that there is an emphasis on very large disasters. So they are not interested at all in small disasters, but they are interested in the most severe disasters and whether they affect economic growth. And this also has to do with their research design, because they want to identify individual events in countries which leads to a significant change in that country's growth trajectory. And they use then a synthetic control method approach to study these one-time events for these countries. So how do they define disasters? For them, a disaster is an event where the share of the population killed exceeds a particular threshold. For example, the threshold corresponding to the 1% most severe disasters in the world. So they would look at how deadly are disasters in the world, how many people are killed in the 1% deadliest disasters in the world, and then they take the smallest of these, or the least deadly of these disasters, and that is the threshold that they apply to whether a disaster is a severe disaster or not. And here they only use the share of the population killed. They don't look, they don't define it in absolute terms, or they don't add this as an additional criterion. Yeah, I'm not sure how well you can see the graphs down here. So this is supposed to give you a graphical summary of their results. I like this study because you get a lot of information graphically. It's much nicer to communicate than regression tables, and it tells you a bit more about the dynamics of things. But here you can see what happens to countries where the disasters are in the top 1 percentile, so above the 99th percentile of the distribution of population share killed. Some people might be wondering if you are familiar with the synthetic control method. Usually the synthetic control method is used to study an individual country. In this case, they use some sort of averaging approach to create or to combine the information of different countries with different counterfactuals. What do we mean by counterfactuals? Now, this is a very super brief and super simplistic definition of or introduction to what synthetic control methods do. Synthetic control methods usually look at an individual country and they try to see whether that country, due to an event that occurs, deviates from what it usually, how it usually would have developed in the coming years after that event. And to really know what would have happened after the event if there wasn't this intervention, if there wasn't exposure to the treatment, they create a synthetic counterfactual. So they use countries which are, before the event, very similar to the country which experiences the event. And from that, they create something like a synthetic artificial mirror of the country that they are studying. And with this synthetic artificial substitute country, they can also map what this country or what this group of country, this weighted group of other countries, is experiencing after the event. So what this means is, and please ask questions if this still all sounds very abstract and incomprehensible to you. I'm not sure to what extent you are familiar with synthetic control methods. I know that Professor Versanigan, and he has posted one article in the chat, he has used this in different contexts, and it's a very, very nice method for quantitative case studies, but it's difficult to fully comprehend it in a less than 5-minute introduction. So the idea is you have your country, let's say Iran, which experiences a disaster, and then you take a couple of other countries which are behaving before the disaster almost identical to Iran, let's simply say on average, or with some weighted average on them. And then you are asking, does Iran after the event still follow the same path as this weighted average for the other countries, or is there suddenly a discrepancy between them? So you are, and this is what we mean, this other group of countries, or this weighted average of other countries, this is what we call the counterfactual or the synthetic control. And what you can see here is that in this case here, with the very severe disasters, you see that there is a gap suddenly. And the gap shows that the actual country, those exposed to the disaster, they are after the event suddenly following a lower growth trajectory than the other countries which were before following the same trajectory, but then didn't experience the disaster. So this would indicate that very severe disasters push countries to a lower growth trajectory. In this figure, oh sorry, I'm not using the correct pointing tool. I should use this here. So in this figure, So I was talking about this figure here on the left. And this is the lower growth trajectory after the event, deviating from the counterfactual trajectory. So what we would have expected if the event did not happen. And as you can see, before the event, the synthetic control and the countries which then experienced the disaster were kind of on the same development trajectory. So if we look at less severe disasters, so here we include everything above the 90th percentile, so this is the 10% deadliest disasters. Here we don't find anything. So this would indicate, and we can also do the same thing for the top 25% of disasters, we also don't find anything which is statistically significant. So this would indicate that it's only the really most severe countries that matter for growth. But this is not where the story ends, because there is an additional argument provided by the authors, or an additional insight, and this I think is a nice illustration of if you find an empirical result, don't stop thinking once you have that result and simply say, this is the answer to my research question. You might still want to think further about what did I find and what does it mean and how can it be challenged. Because what you see here is that if you look at the large disasters which are not followed by a political revolution, so this is using the top 1% as on the previous slide here on the left. So if you are looking at those which are not followed by a political revolution, then there is no significant difference between countries experiencing a disaster and their counterfactual. And there are only two countries in this data set which seem to be driving the difference which we observe here. And these two countries are Nicaragua and, nicely for our purposes here, Iran. And the argument, therefore, is the argument that they are presenting is that the difference here in the growth trajectory really comes from the fact that these two countries, either around the time of the disaster or a few time periods down the road, I assume this is a few years or months, I'm not sure, I would think it's years, down the road, are then experiencing a revolution. And the revolution is the event that actually leads to the discrepancy in growth. And yeah, you can also see Professor Farsanigan's paper on that. So he makes that point using synthetic controls. And they are arguing that the disasters only matter in these two cases. So now you can interpret this in two different ways. You could either say, we had many countries experiencing disasters and in none of them really anything happened. And then there were two countries in which these disasters occurred and there also nothing happened. But randomly, accidentally, these countries at the same time or shortly after experienced a revolution. And this revolution is what was economically harmful. So this revolution is what destroyed a significant share of the country's GDP. This would be one interpretation, saying disasters don't really matter. The alternative interpretation, which would say disasters might still matter, and I don't know enough about these events to choose which of these explanations is more realistic. But the alternative would be that the occurrence of the disaster was contributing to the occurrence or to the severity, to the extremeness of the political revolution. So the political revolution maybe was more powerful or was even happening in the first place due to the earthquakes happening around the same time or sometime before that. I don't want to start the discussion because I'm really not an expert on these case studies, but you see that you can interpret the evidence in different ways. But no matter whether you think that the earthquakes contributed to these revolutions or not, in any case, you see that it is not the disaster itself which was driving these results, which means that the Cavallo and co-authors study, by focusing on the most severe events, does not really find evidence that these major events do have significant growth effects. So let's continue going through these studies. I hope that we can rather quickly talk about these economic effects, because for me personally, the political and social effects are even more exciting. As I explained before, the economic effects have been an important part of the literature, and there's a lot to be learned from these. But of course, all of them are looking at somewhat the same things. So substantively, one in the end can simply draw one conclusion from all of these studies together. But I think they are more supposed to serve here as an illustration of how a literature evolves around a research problem and how people over time have chosen different approaches to address a particular research question and the challenges that come with it. So the next study I want to briefly talk about is the one which has been mentioned earlier by Felbermayr and Gröschel. And the main trait of this study, the distinguishing feature of this study, is that this study is not using primarily the MDAT data that we've been focusing on so far, but they are making the argument that actually you should be measuring disasters to link them to economic growth by their physical characteristics, by their physical traits. So they are focusing on geophysical and meteorological disasters, so disasters for which you can measure the intensity objectively. We discussed that before. Rainfall, Richter scale information on earthquakes, things like that are used to construct an index of the disaster intensity. And what they find is a negative and robust average impact. That's somewhat a duplicate here, effects of disasters on growth. Interesting as mediating factors is that international openness and democratic institutions reduce these adverse effects, which means that if you are as a society more democratic or more globalized, then the same physical events, the same triggering natural hazard events, events of the same physical intensity will have less of an effect on you compared to a country that is less globalized or less democratic, which probably has to do with the fact that these countries are better able to mitigate or have been taking more preventive measures to deal with disasters and their consequences. So here you see a nice summary of their results, because what Felbermayr and Gröschel do is not only claim that you need to use these physical indicators, but they also try to demonstrate that by comparing them to other indicators that is first of all the MDAT data, and then there's another data set that we don't need to talk about here, which kind of serves the same purpose of showing that you find these results by looking at these physical traits, but not if you look at these indicators here. Although, as we have seen, you can construct these indicators regarding the human toll of a disaster quite differently, and I think it's not 100% clear if, depending on if you construct these indicators differently, you might also find negative effects. Simply the fact that in a few regressions they are able to construct indicators that don't show adverse effects here, unlike the indicators which they prefer, does not mean that you cannot construct indicators from the MDAT dataset that would produce significant results. So yeah, to be taken with a grain of salt, but this is at least what they argue they find. So these columns 1 and 2 show two different indicators which they construct and which are supposed to measure the aggregate physical impact of these disasters. Then there's another study linking disasters to growth, and this is also something that has been mentioned before as an idea. The study by Klomp is looking at nighttime light intensity data. So I assume not everyone in here will be familiar with this concept, but it's a very interesting concept, and a more recent trend of research is exploiting this kind of data. So to give you a bit of background why this data is used, when we are working in a cross-country setting, we often face the problem that countries we are interested in studying have not very high quality national statistical systems, which means that even basic indicators like a country's GDP or GDP per capita can be quite substantially biased in such countries. So if, for example, a lot of economic activity is taking place in the informal economy, then national statistical authorities will find it very difficult to account for these things. They will either completely ignore them, or they will have to make a very crude estimate, rule of thumb wise, how big these are, and then try to adjust their GDP measures with some formula to include these characteristics. So informal economy is not the only problem. There are many more problems. It's difficult just to get the data of sufficiently high quality from individual firms in the country on what they are producing. Professor Versanigan has also studied the informal economy quite a bit, and apparently also using nightlight data. This is something I didn't really recall, but good to see that. So this is the problem. Now, why do these nightlight data provide a solution to this problem of not so high quality national statistics? If we cannot rely on GDP, we have to somehow differently measure economic activity. And someone came up with this clever idea a couple of years ago, that what you can actually do to estimate, to guess how wealthy, how well doing a country or parts of the country are, is you can simply look from the sky down to this country at night. And you can simply ask, how bright are the lights burning in this country? So how intensive are light emissions in this country during the night? And the idea is simply that if the economy is doing well, if you have a lot of economic activity, then this is highly correlated with high night light emissions. So this country will be pretty lighted up during the night. Because they have electricity everywhere, and that electricity is also used to light buildings, roads, production facilities, private homes, etc. So this is a somewhat indirect measure of economic activity. It's not directly measuring the production process in a way that we usually would do it. but it's measuring all kinds of production and consumption that are going on in the country, and it's supposed to substitute national statistics, especially where they are either not available or where they are of questionable quality. So the argument is not that nightlight data is very good to measure GDP in Germany or in France. Actually, it's not really an ideal measure for such countries, because one problem that you face is that at some point the scale of nightlight activity is capped, because a place cannot get brighter in the night from a certain point on. And also people living in these cities will start complaining if there are too many light emissions. So then governments are actually regulating the light emissions down, which would mean that these countries would become poorer, but which in reality is not the case. So for very rich countries, these are not ideal, but for poorer countries and countries where statistical capacity is low, it has been shown that this is a very nice substitute to official statistics to measure economic activity. And one big advantage of these indicators is that you can also use them at the subnational level. Even if you might not have GDP estimates for that country available for individual regions or for individual cities, the nightlight data you can break down to any kind of geographical scale and unit. So that is very nice, very helpful. That you can, using this data, you can do subnational analysis quite easily. And this is also what this study by Klomp is doing. So Klomp, on the one hand, can argue that his nighttime light intensity data allows him to study some disaster-affected countries better than we would otherwise be able to do it, because the statistics, especially after a disaster, the statistics might not be sufficiently reliable. And the nightlight data might actually be better, but on top of that, it allows him to look at the subnational level, so to break it down to the effect on individual regions of a country. So how does he define disasters? So far, I've only spoken about the dependent variable here, which is these nightlights. Disasters are defined, again, according to a number of criteria, at least one of which has to be fulfilled. So the number of killed should be at least 1,000. The number of injured should be also at least 1,000. The number affected is no less than 100,000, and the amount of damages is no less than $1 billion. I think this should be the same characteristics as applied by the study of Gas Ebner. So they are using the same criteria to identify what counts as a disaster. But then Klomp also does one more thing. He distinguishes 4 different categories of disasters: hydrological, meteorological, geophysical, and climatic disasters. And he then, like the study by Gas Ebner and co-authors, he also normalizes by land area. So this distinction to different disaster types we'll come back to in a moment, because the idea is that they might matter differently due to different traits, something that we talked about on Monday. I think this graph here from the Klomp article is quite nice, because it's one of the few times that an author is actually explaining exactly what we could expect from a disaster. So what kind of growth trajectories could we see if a disaster has an effect on economic growth in a country. So a very simple effect could be scenario A, that there is a temporary economic downturn, an economic decline, but that the country at some point is able to catch up to its original trajectory. So this would mean effects are purely temporary. The country temporarily is poorer, but then it converges back to its original growth trajectory, which would mean there are short-run effects in the country, but no long-run effects. Scenario B is very similar to scenario A, with the only exception that in the recovery process, the country might be somewhat overshooting, might actually, due to the substantial growth in the recovery period, might actually move even beyond the original growth trajectory. One contributing factor might be the renewal of infrastructure and technology that we already discussed on Monday as a potential argument. But the argument with scenario B is still that the country would be returning to its original trajectory. Scenarios C and D are similar to scenarios A and B, with the only exception that they do not assume that the country in each case returns to the original trajectory. In scenario C, the idea is that after the downturn, the country never fully recovers, so it stays on a lower trajectory, meaning that there is permanent damage to the economy due to a large-scale disaster. And in scenario D, you have an extension of the case of scenario B, where we would argue that there is a downturn, but in the recovery, we actually reach a higher level of long-run growth than we would have had otherwise. So this is really using the assumption that the disaster has this creative destruction aspect. So this Schumpeterian aspect. What did I say? Creative destruction. Yes. So the idea here is that you will have additional technology adoption. You will have replacement of old forms of organization, breaking up of rigid market structures, etc. And after a short recovery or a short downturn and then a short recovery period, we will be permanently on a higher growth trajectory. So in that sense, disasters could be something advantageous if they are hitting very rigid economies and forcing them to renew themselves and breaking up these rigid structures in the economy. So these are 4 different theoretical scenarios. We don't need to go into the details of these and how they are exactly reflected in the data, but I thought for the theory, this is a very nice addition to present these arguments here. So this is one of the studies which invested a bit more effort into explaining exactly what theory could predict. Also a nice feature of this study is that there is an overview of the different disaster characteristics. So as I told you, Klomp is distinguishing geophysical, meteorological, hydrological, and climatic disasters. And here you can see that depending on the category, you can expect different physical damage levels. So geophysical disasters and meteorological disasters should be much more harmful according to this description here than climatic disasters, where we have been talking about things like wildfires. In terms of the population affected, however, it could be exactly the opposite, that a geophysical event might lead to more physical destruction, but less population affected, especially if you take into account the possibility of preventive measures. So we don't need to go through all of these. Maybe one thing that has been mentioned earlier in the student presentation, these event types differ in terms of their duration. So here we have geophysical events which are very short, usually in duration, can be over in minutes. Meteorological events, a storm, for example, which can go on for hours or even days. Hydrological events, which can go on for weeks, like floodings, for example. And also climatic events, fires, which can also be a very enduring problem, especially if one does not have the capacity eliminate these fires, or if the landscape is such that they will break out again and again due to lacking humidity or the landscape being too dry. Okay, and we should not confuse this time scale of duration. We should not confuse that with the time scale of the effect. Even if a event like a earthquake is rapid onset, so it happens spontaneously and in a short period of time, it could still have quite long-lasting consequences. So there are some other characteristics here, but I don't want to go through all of them. I think, nevertheless, it's an interesting table to study when you are asking yourself, what disaster categories should I be working with for my research problem? So this is some of the results that the study by Klomp is producing. As you can see, the dependent variable is change in light emissions, and light emissions, again, are an indicator of economic activity, so you can interpret this as an indicator of economic growth. So how is economic growth affected by the occurrence of disasters? And you can see here, I've cut off this table below a certain point, so we don't really care about the difference between 1 and 3 and 5 and 7. These are different model specifications with different control variables, but you see only the variables that we care about. And here you can see that overall large-scale natural disasters reduce economic growth. And you can see in column 2 that once we try to distinguish different disaster types, different categories of disasters, we find this effect systematically, robustly, for 3 out of the 4 categories of disasters. So meteorological, hydrological disasters, and geophysical disasters are the ones which reduce economic growth, whereas climatic disasters also show a negative sign, but this effect at least is not estimated precisely enough to take it as convincing evidence that there is a negative effect. So as you might have noticed from the title here of the table, these are the short-run economic effects. So this is really the contemporary effect. This study is using an approach that I explained earlier today, that there is a weighting of the disaster. So if the disaster occurs early in the year, then it's almost completely attributed to this respective year. But if it occurs later in the year, then it's only partially counted towards this year and partially counted towards the next year. So this is, in this sense, the contemporary effect. So the effect either in this year or in the following year, or usually a mix of the two. But it's not the effect over a couple of years. So it's really what's happening in the short run. And in that sense, we are only looking at the question, are we in scenario, I mean, in essence, you could say this is compatible with all 4 scenarios here. Scenario A, B, C, and D all assume that there is a decline in the short run, and this is what we find. So this would not really help us to distinguish these different scenarios. What we find when we look at the long run is that most disaster types have no long-run growth effects. There is one exception, which are geophysical disasters. They even show a positive effect. So if we want to link that back to our disaster scenarios here, this would be consistent with scenario A for 3 of our 4 types. However, geophysical disasters might even fall into scenario D. For scenario D, I've so far stressed that these societies might be innovating, might be modernizing. One thing that I've neglected to mention, and you've discussed this earlier with me already, is of course this idea that these societies might also get a lot of external support. So one reason why there is this quick recovery and maybe an overshooting of the recovery might be, of course, a lot of foreign aid and remittances and other ways of other reasons for financial inflows. So this might, maybe this is more of a case in case of these large geophysical events. So an earthquake might trigger more of an international response, might lead to more donations and state support, foreign state support in rebuilding a country, and that might help these countries to even move to a higher growth trajectory than they were on previously. This in combination with the modernization effect. Okay, so these are the long run effects. Then another interesting insight, I've already mentioned that this data allows us to look at the subnational level. And this is what Klomp also is doing. He's comparing which share of this effect of the disaster concerns the particular region in which the disaster strikes, and how much of the effect comes from the remaining regions of the country. So how much is a spillover? So say in one region a earthquake hits, what is the share of the negative growth effect that happens in that particular region, and what share of the negative growth effect comes from the other regions which are indirectly affected. For example, because they don't get any inputs anymore, or any agricultural products anymore, any consumption goods anymore from the affected region, and are thereby also harmed. And what Klomp finds is that these disasters tend to be highly regional, in that 75% of the economic impact takes place in the particular region where the disaster strikes, and only 25% take place in all the other parts of the country combined. So most of the adverse effects of disasters are local, are regional. He also looks at smaller scale disasters, which were previously excluded in the definition of disasters, and he finds no evidence that they have any effect. Moreover, he finds that if you distinguish between large and very large disasters, then very large disasters are the ones that are driving the results. So the very large ones have even stronger effects than the large ones, which means small disasters up to a certain point, they don't really matter. And when you have larger disasters, they matter for economic growth. And when you have even larger disasters, they matter a lot. The question in the chat, how the short and the long run are defined. Short run means something like in this year, in the next year. As I told you, this is both taken into account depending on in which month of the year the event happened. Whereas the long run here, I think, is a period of 10 years. So if you find, he looks at these individual years after the event, and then he also creates an aggregate growth effect over this 10-year period. And in 3 out of the 4 categories, this aggregate effect over the 10-year period is not different, is not significantly different from 0. And for the geophysical events, interestingly, it's positive, because these countries, after a couple of years, they have this positive effect which outweighs the short-run negative effect. So the geophysical events also have the short-run negative effect, but then after a few years, as you can see it in this one scenario here, in scenario D, then here you have suddenly a strong positive effect, and that effect is so positive, or so big, that it outweighs the short-run costs, and it stays overall on a higher trajectory. Final result from this study, I think it's a very rich, very complex study looking at many things. So the Klomp paper is a very good one, I have to say, just by the number of things that the author looks at. But it's generally, this guy is someone known for producing very interesting studies. Here we are looking at mechanisms, and mechanisms again means what are the transmission channels, what is mediating, what is determining how severe a disaster affects the economy. And here he's distinguishing different country groups. Also here you can see the time scale. So this here is the effect after 10 years. This is the effect in the same year. And you see that mostly we don't see any long-run effects here because we don't have long-run effects overall disaster categories, only in that particular geophysical disaster category. And here we find that low-income countries are the ones which have the significant negative effect from large-scale disasters. And here, not only in the short run, but you still find even an effect in the medium run, so after 5 years. You don't find that over all countries, but when you only look at low-income countries, you still find that. In high-income countries, in contrast, you see that they simply have the means to shield themselves better, to prevent better the consequences of disasters. They also have, yeah, we will come back to the second point. These countries simply don't show any significant negative effects. Financially constrained countries have a larger effect. So countries in which financial markets are not as developed, I think, is the distinction. I don't think this is government financial constraints, but this is financial markets development. And here you can see if you don't have functioning financial markets, the effect is twice as large contemporaneously, and it also is more long-lasting, still to be detected after 5 years. If we distinguish according to globalization, something we looked at earlier, closed economies are hit twice as hard as open economies, also with a more long-lasting effect. If we look at the political system, we see that autocracies are hit harder than democracies. If there's a difference between low-income countries and financially constrained countries, if I interpret your question correctly, I think it's not clear whether it's due to the fact that these countries are low income or due to the fact that they are financially constrained. It can be one or the other. So these are transmission channels that are consistent with an effect, but you cannot really say that it's because the country is low income or because it's financially constrained. I don't think the study would have sufficient data to disentangle these mechanisms from each other. Yeah, so I hope that answers the question. So these are to be seen as alternative transmission channels, but we cannot very clearly identify whether one or the other transmission channel is decisive. Just a second. Okay. Political systems, we see twice as large an effect in autocracies as in democracies. And regarding aid dependence, here we don't really see any significant difference. So whether a country depends on international aid or not, this does not seem to make a difference for how much they suffer from international disasters, from natural disasters. Okay, so this is just some information on potential transmission channels. So it might be better to have high income. It might be better to have functioning financial markets, to have an open economy, to be democratic. And if you have these characteristics, then you are better shielded, or then you are largely shielded against the economic effects of disasters. Anyway, most of these characteristics are desirable, so it's not like we need additional incentives for countries to strive after them. But you see that in the disaster consequences, you see one additional argument why it's good to have a high income, to be financially developed, etc. Good. This study, which is mentioned here briefly, is something I've indicated before, that this has been studied. This is a short research note which simply looks at the question whether countries are affected less economically by disasters when they have functioning insurance markets. So if the private insurance penetration, if the functioning of the insurance market is better, so if it's easier to get private insurance and there is more private insurance against disasters, then countries, as they are able to show empirically, suffer less from natural disasters. And this is even complementary with the otherwise overall institutional environment. So having better institutions is good, like being democratic is a good thing to reduce the impact of disasters. Having private insurance is good, and both in combination is even better. It seems that this could be seen in combination with this financial constraints arguments tested here. But here they are explicitly looking at insurance markets. Then we are soon done with the studies. The Caruso study, which I mentioned here, is interesting because this author looks at the effects on individual people and how people's labor market participation, education, etc., is affected by them being exposed to natural disasters. They are studying only Latin America, but over a very long time period. And what they find is that natural disasters affect education, health, labor outcomes, and wealth of individuals. And the effect is the strongest if an individual was an unborn child or a young child, or at least in school age, while being exposed to the disaster, which means that if you're exposed at a very young age, then you have the most adverse consequences of a disaster, probably because it negatively affects your health and your education, and you carry that burden with you for the next years or maybe for all years of your life. So this indicates that young people are particularly suffering from such disasters. It's of course an interesting take if you link it to the COVID pandemic, where it's also argued that in countries which have been shutting down schools due to COVID, that young people will be carrying large parts of the economic burden because their education suffered, and they will have to pay the price for that for the rest of their lives. Whereas other people who were not getting sick and who were not at school age, they might overcome the costs of the disaster relatively quickly. Interestingly, this is even something that's intergenerationally transmitted, which means that if your parents are affected by a disaster, that affects your education as well. And the effect is stronger if your mother is affected than if your father is affected. By the way this study is constructed is that they are looking at very local effects of disasters. So they are looking at where people grew up and whether these places were affected by a disaster locally, very locally, during a particular period of time. So this is how they try to disentangle how, for example, different parents were affected because they grew up in different places. Okay, this is the final study. I'll not say much about this, but this has been mentioned earlier, I think on Monday. We briefly talked about the issue of migration, and this is a study only looking at the United States over a 90-year period. And what they find is that in counties, so in small administrative districts that are affected by severe disasters, severe here with a very low threshold in the US, severe can be defined by 25 people being killed. In most places that would not be considered a severe disaster, but you see that the United States is so well shielded against the harm of disasters that usually not so many people get killed. So you can use a very low threshold. And the consequence of that is that out-migration rates from these counties increase, which means that after such, or in the decade in which such a disaster hits, people are 1.5 percentage points more likely to leave that county. And at the same time, and this is interesting, the housing prices and rents are reduced by 2.5 to 5%. Now, usually if you are hit by a disaster, you would think that housing prices and rents should increase. First of all, because some housing will be destroyed, which means there should be more scarcity of housing, which means that the prices should increase. Sorry, I started that with first of all. That was not what I wanted to say. So if there's destruction of housing, on the one hand, this should actually increase prices. But we see that prices decrease, which indicates that the effect goes along with the out-migration effect that we observe. So it seems that it's becoming less attractive to live in these places. So one story could have been people are leaving because some houses have been destructed, and living in the remaining houses now is more costly because there are fewer houses and it would be costly to build new houses, so people are leaving therefore. But this is not what seems to be the case. What seems to be the case is people are leaving because of worsened economic prospects, because the local economy is permanently harmed. It's become less attractive to work there, to live there. And that is also what's driving down the housing prices and rents significantly. So people are not willing anymore to pay as much for housing there, simply because if they take a job there, they cannot generate the same income. Or if they open a business there, they cannot generate the same income. And there also seems to be a related paper by Professor Versanigan. I think he has a paper on everything that we look at here. So you should probably just read through his CV and you'll find the corresponding results for Iran. So again, we find that more severe disasters have stronger effects. And as I indicated, it seems that the adverse effects on the economy seem to be more important than the destruction of local housing stocks, which explains why, in spite of destruction, housing actually and rents actually become cheaper, which might be unexpected. Okay, so these are the economic effects. What are you supposed to take away from this? First of all, there are different dimensions of the economy that you can study. You can look at individuals and how they are affected, maybe over their lifespan. You can look at topics like trade. You can look at topics like migration and market prices, as is the case in the last study that we looked at. Or you can look at the big question, which is economic development. The studies I focused on are cross-country studies. Of course, there are also a couple of within-country studies, but not very many. So this is an area of research which can certainly grow further over the coming years, with the exception of Iran. I think on Iran, Professor Versanigan has done anything that can be done. But there are other countries which can also be studied. And maybe he left one or two research gaps. Yeah, so with regard to the big question of economic development, we seem to see that there is an adverse effect, but it depends on how exactly we measure disasters and how also we measure economic activity. But my take on this, my interpretation of the evidence that I've presented to you is there seems to be a short-run negative growth effect. It's unclear how it is in the long run. It could be that these economies completely recover, but we don't know to what extent this is because they recover out of their own capacity to recover, or to what extent this is due to international support. But they seem to be able to recover overall. But it might take a couple of years, particularly in poorer countries. And of course, still there is a humanitarian toll, even if the economy is not permanently damaged. This affects people's education, people's health, and of course, people die from these disasters. So even if we find no long-term economic damages, these disasters are obviously still pretty damaging, harmful. Okay. Now we can move to the final slides if there are no questions regarding this, which so far does not seem to be the case. Let me see, where do I have them? Here. So I'll try to move at least through large parts of these because I think these are quite interesting studies. So now we've looked at something which was a bit monotonic, a bit one-sided, because we were always interested in economic activity. But in this part of the lecture, we look at very different outcomes. So every study will be looking at something else. So in the first study that I want to present to you, Thomas Plümper and Eric Neumeier, so this is a political scientist and an economist from the London School of Economics. Thomas Plümper is in Vienna. These guys have done lots of studies on natural disasters, so you will come across some of their articles in the literature that I provided you with, but you will find that they have even more articles than that, and also they are right now working a lot on COVID. So if you are interested in the effects of COVID, you should simply look at their websites and you'll find published articles and a large number of working papers of forthcoming studies. So this is a study which they published quite a while ago, where they are testing a famous hypothesis by Amartya Sen. I hope most of you will be familiar with the name. Amartya Sen is a Nobel Prize winner in economics, a very famous development economist. And Amartya Sen has once formulated the argument that in essence, substantial famines and substantial famine mortality is not really a natural event, it's a political failure. And his argument was that actually substantial famine mortality does not occur in democracies if you look at the data. And it almost exclusively occurs in autocracies because autocracies respond less to the needs of their citizens or of all of their citizens. And therefore, democracies are able to largely mitigate the adverse effects of famines, to largely avoid death. Whereas autocracies simply accept that parts of the population might die, and they might focus more on mitigating the economic consequences, or they don't even try to mitigate the consequences at all, because they are mostly focused on a small elite and their interests, which are not affected too much by famine mortality. So this is the argument of Sen. Plümper and Neumeier then tried to test this, and the results are nicely summarized in this graph here. They even go one step further by adding international food aid to the equation and arguing that it's not only democracies reacting better to famines, But on top of that, if you give democracies food aid, they will distribute it better. They will use it more to actually avoid starvation, and might not use it, for example, to enrich themselves. And therefore, they also are able to use this food aid more to reduce mortality in their countries. And these are the two arguments which are nicely depicted in this graph here. So this is why I don't show you any regression coefficients, but I show you this graph here. So first of all, this curve here, famine mortality in autocracies, is always higher than famine mortality in democracies. So this is the predicted mortality based on a regression model, is higher in autocracies than in democracies, independent of the level of international food aid that the country receives. So this underlines the first point. Famine mortality in autocracies is higher. But interestingly, you see that this curve here is flatter, especially here early on, than the famine mortality curve in democracies. So if you give democracies 100 metric tons of international food aid, they eliminate mortality almost completely. So they move from this point here down to this point here, which is a reduction by, I would guess, 90% or more of the mortality. Whereas the autocracies who start from a significantly higher level, if you give them the same food aid, they are not even reducing their mortality by 50%. So it's a dramatic difference. Here the curve goes down very steeply. Every unit of food aid you give them helps them to reduce mortality substantially. And then at some point there is not much mortality reduction to be done. And here the curve is much flatter. So non-democracies seem to make less efficient use of these resources. Okay, so this is one study on government responsiveness, so how governments react to disasters. There's a complementary earlier study dealing with something similar. This is a study by Besley and Burgess looking at Indian data, and they are arguing, they are predicting theoretically that governments should be more responsive to disasters where the government is more accountable to the electorate, so where elections are more competitive, where they are closer, where there are more parties competing, etc., and also where people are better informed. So political activity, political competition on the one hand should make the government more responsive, but also better information of the citizens should make the government more responsive. And they are measuring this in terms of two policy instruments of the government. One of them is public food distribution, and the other one is relief expenditures. So they are linking relief expenditures specifically to flood damage. So flood damage destroys infrastructure, housing, which needs to be rebuilt. And the question is, under what conditions are governments offering more relief expenditures to rebuild? And on the other hand, they are looking at adverse agricultural production shocks here, indicated by food grain production. And they are asking to what extent the government reacts by distributing food publicly. And we don't have to go through the details of these regression tables. Given time, I'll just quickly summarize. What they find is that the responsiveness of the government depends on the informedness of the citizens, which is measured by newspaper circulation. So in Indian states where there is higher newspaper circulation, the government will react to the same crisis in terms of food grain production by providing relatively more public food distribution. If there is more newspaper circulation, they will react more strongly. And also, if there is flood damage, the government will, given newspaper circulation is high, they will also react more strongly by providing more relief expenditures. This table here, we will not go through the details of that, but this tests the second part of the argument, whether political competition adds to the government's responsiveness, and you find the same thing. So public food distribution to respond to lower production in agricultural output, as well as relief in reaction to flood damage, both of them increase if political actors face more competition, if there is more voter turnout, etc. Yeah, we don't have to go through the details. I think the underlying argument has become clear, and this gives a more fine-grained answer than the Plümper and Neumeier article. They are just saying it's democracy, and here you see it's not just democracy overall, it's the combination of political accountability, but also the informedness of the citizens, which matters, that politicians react. Another interesting study, and this is the final study regarding government responsiveness to disasters, comes from Kiefer and co-authors. Philip Kiefer used to be at the World Bank, is I think now at the International Development Bank, and is a well-known development economist. And these guys have studied how governments are able to reduce the death toll of earthquakes. So how they regulate earthquake mortality, you could sum it up. And what they find is that mortality overall following earthquakes of the same size, mortality is lower in countries with a higher earthquake propensity. So this is interesting because it links to something that we discussed in the measurement chapter. In the measurement chapter, I argued that a government or a country which continuously experiences disasters of a similar size will not consider them adverse shocks anymore, because for them it's kind of the status quo. So if you have monsoon rain every year, it's not the same as if the same rain hits a country which never has flooding and intensive rain. So what this shows here, if countries are used to having earthquakes, if the earthquake propensity there is high, then the death toll from an individual earthquake will be lower, because these countries obviously take more preventive measures. We also find once more that mortality is higher in poorer countries, or in other words, poorer countries respond less to the earthquake propensity. So the increase in preventive measures that you see in high propensity countries is not as significant in poor countries as it is in rich countries. So particularly rich countries that experience many earthquakes, they will be very, very well protected. Whereas poor countries that experience many earthquakes, they will only be somewhat well protected. A good example would be Japan, which is relatively rich and has been investing a lot of resources into protecting themselves from floodings, from earthquakes, etc., which they are exposed to quite a bit. Also, we see that mortality is higher at any level of earthquake propensity, so this is independent of the propensity, when governments have fewer incentives to provide public goods, and they use, again, the aspect of autocracy here as one thing that contributes to mortality, but also something that we discussed earlier, corruption might also be a problem. So you see that corruption has a complex relationship with disasters. On the one hand, we argue that corruption might increase due to disasters, but also corruption can increase the effects of disasters. So if you are exposed to the same earthquake, a country that is more corrupt will have a higher death toll, probably also because they are not using public resources as efficiently and will be not as well protected as a government with lower, or a country with lower corruption levels. So this is everything about government responsiveness. I've not seen any questions or comments so far in the chat, so my assumption is either you've already fallen asleep, which would be 20 minutes too early, or so far everything seems to be clear. Please feel encouraged to interrupt if anything is unclear. Otherwise, I will continue, and there are only a few more studies which I wanted to discuss. But of course, questions in between are still very welcome. So here's a study, the one by Brückner and Ciccone, published in a high-ranking economics journal, was very influential and triggered its own literature. And this relates to a point that Sven Fischer raised earlier, namely measuring disasters in a different way than by their human or humanitarian toll, measuring them in terms of their physical traits. So what Brückner and Ciccone have been doing, they have been studying adverse economic shocks due to variation in rainfall. So they have been asking if rainfall significantly deviates from the usual rainfall for that country, does that have political consequences? And their argument is that if a country has significantly reduced rainfall, that will of course reduce agricultural production, and this will lead to conflict, for example, over resources. Also possibly conflict because of flights, people fleeing from the areas mostly affected by this. And all of that might contribute to conflict, and this conflict leads to political destabilization. And so it might be that this is a contributing factor to autocratic governments collapsing. It's a very interesting argument if you hear it for the first time. For someone like me, it sounds very natural because I've heard this dozens and dozens of times. This is something that's now a standard argument in the literature. But when you hear it for the first time, it's a bit counterintuitive that you expect a positive effect on politics if something bad happens, like a disaster. But the idea is that the occurrence of a disaster creates this window of opportunity for political change. So it destabilizes the political regime. It can also destabilize the democratic political regime, which might be something that we might be more concerned about. But it can also destabilize a non-democratic political regime. And then there is a certain chance that this non-democratic political regime will be replaced by a more democratic one. So regarding that question, political change in which direction, the main part of the argument is that it destabilizes the political regime. So it could be that autocracies become more democratic, but it could also be that democracies become autocratic if they are affected by such disasters. This does not seem to be the case in the same way, which might have to do with the fact that democracies shield themselves better against disasters. So there might not be as much turmoil, as much unrest in a democracy affected by a disaster, simply because they take more preventive measures. They mitigate the consequences of the disaster better. So it's not as destabilizing for these political regimes. Whereas autocracies seem to not mitigate these effects as the effect as well, and therefore it destabilizes them. So it's not the fact that it is not that something is specifically pushing these countries in a certain direction. The argument is more this idea of a window of opportunity. So the idea is whenever an autocracy collapses, it can either be replaced by a new autocracy or it can be replaced by a democracy. So it's not clear that it always has to be the case that when a political regime is destabilized, that an autocrat will be followed by a democrat, but there is a certain probability. So the idea is every time you experience the stabilizing effect, you flip a coin or you throw a dice or something, and with a certain probability, you might transition into a democracy. So the window of opportunity is no automatism. It does not ensure that you have a transition, but just it creates the opportunity. And if you have sufficiently many of these opportunities, then your chances at some point are quite good that you will transition. So this is how the argument goes. Yes, indeed, it might depend on the financial resources of the autocratic regime, but it's also a question of how responsive that regime is, because even if it has the financial resources to mitigate the consequences of the disaster, not every political regime will consider it sufficiently necessary to do so. And the thing with destabilized autocracies is that it's sometimes difficult for the rulers to judge well how stable their regime is. So this is this old Timur Quran argument. If you are living in a democracy, then everyone says openly what they think of the government. And if you don't like the government, you'll say it openly. So the government has a good idea whether people like it or dislike it and how many people dislike it. Whereas in an autocracy, the autocrat doesn't know exactly because people will not say it openly. The more autocratic the country is, the more difficult it becomes for the dictator to judge how safe he is in his job, because the less people will be willing to speak out openly. And so many people might be unhappy, but they might not be saying so publicly. So in that sense, sometimes an autocratic regime might have the resources to mitigate the consequences of a disaster, but it might not find it necessary to spend them because it might not be fully aware how dire the situation is for that government, how likely it is that unrest breaks out, etc. Yeah, I mean, if you think about it, with the Arab Spring events, if governments had anticipated them, if they had known what the potential for social unrest was in some of these countries, for example, in Tunisia, they would have just spent a bit more money. They would have just they would have just reduced some of the economic inequalities just to the extent necessary to keep the political system stable. But it's difficult to anticipate when you are in such a situation. Yeah, governments can, of course, also exploit such disasters, obviously. So that is why not every disaster will be perceived as mismanagement by the government. And you see, for example, that the Chinese government nowadays would react very differently to a disaster than it would have done in the past. Nowadays, it would react by mitigating the consequences of the disaster to a large extent, and portraying itself publicly as the savior of the poor affected local population, and use that for propaganda purposes to stabilize, to improve its political hold on power. Whereas in earlier times, the Mao Zedong times of China, this government had no problem with having thousands or millions of people starve. So this is also a very different approach of different non-democratic political regimes, depending on how they think it's best to consolidate their political power and at the same time maybe to get some of the economic resources for themselves. Difference between resource rich and resource poor, I don't really know whether this has been studied, to be honest. I would assume that this has been used as a robustness check here and there, but I don't recall any study focusing on that question. Exactly. The Arab Spring countries started spending once it happened, but only some of them were able to get things under control. So as we saw, the governments in Tunisia and in Egypt had to go. Tunisia now has a democratically elected government. In Egypt, things evolved somewhat differently, and they moved back to, let's say, these somewhat same old elites being in power, with a short prelude. But as you are pointing out correctly, the other countries were able to get things under control in time. Yeah, it's not, as I said, it's not an automatism. There's this window of opportunity, and with a certain probability, you could see such a democratic transition. And if you take the Arab Spring as something similar to the shock that you might experience if you had a natural disaster, then you could say that Tunisia would be the case where transition happens and is successfully consolidated, at least up until now. Egypt is the case where there was also a transition, but it was not successfully consolidated. And then there were a number of other countries which were exposed to a similar shock, maybe not the same shock, but also to some shock. But they managed and they did not transition. So these governments stayed in power. Yeah, so this is an interesting theoretical concept, and this paper has become famous for showing that an income shock of 1% leads on average to an improved democracy score of 0.9 percentage points. And the probability of a democratic transition increases by 1.3 percentage points. So this does not mean that every single country that experiences such an adverse shock due to rainfall or something else will become a democracy. But the more sizable this income shock is, the more likely it is that you have a democratic transition, simply because it makes the collapse of the current political regime more likely. Here you see a couple of examples from this article. So this, I think, is a very nice illustration. On the vertical axis, you see democracy scores going from complete autocracy to complete democracy. And you see on the horizontal axis, they always indicate when droughts occurred. And in all of these cases, these are of course not random cases. You should not think they've randomly picked out a couple of countries. Here they have picked countries which support their arguments. So this is an illustration of how things could be going. This is not showing that this would be happening in every single country. But you see that there are quite a number of case studies which are consistent with the narrative that pretty much exactly at the time when the drought occurred, or very shortly after, you see that these countries move up the democracy scale. Some of them stay up and some of them come back down, as you see in Niger or Sudan. These countries, there it was not a sustainable transition. Okay, moving to a different topic, but one that I don't want to keep from you because I think it's very interesting. And this is a study by a economist from Copenhagen, who has looked at the effect of disasters on religiosity. And this is a big study. I'm only giving you a short excerpt of her results. So she's looking at whether experience of earthquakes is associated with higher religiosity, the argument being that religion serves a coping mechanism for people. So we deal with unfortunate events, with the uncertainty of life, with the complication of life and all of these things by turning towards religion. So religion helps us coping with adverse life events, with adverse events like disasters. And based on this argument, Janet Benson predicts that in societies which experience more frequent disasters, and particularly after a society experiences a disaster, there should be an increase in religiosity, because people then turn more to religion. One aspect of the evidence she presents is cross-sectional. So she shows that cross-sectionally, in regions where there is a higher earthquake propensity, there are higher levels of religiosity. But especially the results that I've given you up here are quite interesting. Here she's looking with a limited sample. She doesn't have a lot of data for that, but with a limited sample, she's even looking at changes in religiosity over time after the experience of an earthquake. And what you see on the left side is changes in people's stated importance of God to them. So God, Allah, whatever you call your God, but their religious figure. This is the stated importance of God according to what these people themselves think or say, express. And you see that this is the level here indicated by the blue points in countries which did not recently experience an earthquake. You see that the stated importance of God tends to be higher in countries which recently experienced an earthquake, and it is even higher in countries which recently experienced an earthquake and which are otherwise rarely hit by earthquakes or by disasters. So this again goes towards this point mentioned earlier, that disasters might be more consequential and more important in areas where people are not used to experiencing them. And subject specific, you see that experiencing disasters, and especially experiencing unexpected disasters, leads to an increase in religiosity. So this would be consistent with this idea that people in uncertain conditions experiencing adverse events turn towards religion. What we do not see, and this is interesting in combination, we do not see an increase in the share of people who are saying that they are religious. So it does not seem to be the case that experiencing an earthquake makes you turn towards religion when you are not religious at all. But for people who are already religious, for them it increases the importance of religion. So they seem to be using religion as a coping mechanism. So earthquakes are not an instrument to turn atheists or agnostics into religious people, but it makes religious people potentially more religious, focusing more on religion. Yeah, so there seems to be a somewhat temporary effect. So the effect seems to be decreasing after a while. So with longer effects, longer time periods, the effect seems to fade out. But interestingly, still you can trace this effect to children of immigrants who experienced disasters in their country of origin. So there seems to be some persistence of the effect across generations. So if your parents come from somewhere where they experience disasters, then your propensity to be religious in the new country seems to be increased by that as well. So the idea being that your parents experience disasters, this makes them more religious, and then they give this higher level of religiosity to you as their offspring. So they teach you, they educate you to be more religious, or you simply copy it from them. Another complementary evidence, and this is quite interesting, I'll come back to that in a second, and this will be the final argument I'll present to you today. People Google religious terms more as a share of their Google searches in US states that were more heavily hit by or that are more exposed to earthquakes, that have a higher earthquake risk. So this is cross-sectional evidence simply saying in parts of the US where earthquakes occur more frequently, people Google religious terms more often. So also there people seem to be more interested in religion. Now, the interesting part is that there is a follow-up study by Benson from 2020 where she looked at Google searches for prayers during the COVID pandemic. And what she finds is that Google searches for prayers dramatically increased during the pandemic to the highest level ever recorded. So that's quite impressive. And this holds for all continents and all religions, although Buddhistic and Hinduistic religions, so non-monotheistic religions, have a significantly smaller effect. But independent of whether people are Christians, whether they are Muslims, they seem to be turning to religion and to prayer during events like the COVID pandemic. And the effect tends to be relatively smaller in poorer, more unequal societies and societies with higher uncertainty. But this is simply because these societies are more religious in the first place. And so they also are more likely to turn to religion then as a coping mechanism. So I think this is quite an interesting and very, very topical result, showing you that one can not only look at growth rates to understand the consequences of disasters, but also you can look at quite different outcome variables, like people's values. This is not the only study. There are other studies, which is also in the literature that I provided you with, that looks, for example, at things like conservatism, which might be affected. But you see that it changes societies on all kinds of levels. It affects our politics, it affects our economy, it affects us on the individual level, how we think, how we behave. And we don't fully understand yet all the consequences of disasters. This is still ongoing research. This is research to which you might be contributing maybe at some point if this is exciting to you. And yeah, there's still a lot to learn, and with all the negative aspects of disasters, with all the harm and destruction that comes with it, disasters simply also provides very exciting natural experiments, situations to study human behavior when exposed to these adverse shocks. Good, that would be my lecture.